Hi friends, well you might have seen in the news that PowerFX functions are now in preview. They're the latest incarnation of low-code instant plugins that are now natively available inside the Power Apps portal. But why do I think that this is such a big deal? Is it because you can now use PowerFX from inside Power Automate? Well, that is cool, but not as big as the feature that I'm talking about. Listen, there has been one thing that pro coders have had exclusive access to up until now, out of reach to low-code Power Apps and Power Automate, and you had to be able to write C# plugins to access this essential feature that all enterprise systems need at some point. I've seen so many intermittent errors that are very difficult to identify and fix, all because of not using this particular technique. So what was the cause? You might think that because we're using low code that you shouldn't have to worry about database concepts such as transactions and concurrency. Well, I'm going to show you why you not only need to understand these concepts, but why you've been missing out on them all this time. Transactions are often referred to as passing the acid test, but more on this in a minute. What about transactions? What are they? If you skipped that computer science class, then here's a quick catch up for you. A transaction is a sequence of operations that either all succeed or all fail, nothing in between, keeping your database nice and consistent. If one step fails, everything else rolls back. It's called an atomic operation. Imagine that you're building a work management system and a user saves a work order that has multiple line items. Imagine if one of those line items has a negative quantity that violates the minimum of one rule. It reminds me of that geek joke about a software tester walking into a bar and ordering -1 beers. So in inserting the two items, if that second insert fails, we're now left with a work order that doesn't have all of its items. This is not good and will need tidying up. When the user retries with the correct quantity, it can also lead to duplicate line items, which is also not good. So to solve this, databases use transactions. They've been around pretty much since the 1960s, and it's still a fundamental part of software design today. So back to the acid test. It stands for A for atomicity, and this is what we were just talking about. It means all operations in a transaction are completed successfully or nothing at all. C is for consistency, guaranteeing that the transaction brings the database from one valid state to another in a predictable way. For example, you might have a unique key that would prevent duplicates being inserted, so that transaction would not allow this rule to be broken. And of course, because of atomicity, any other operations in the transaction would also not be applied. I is for isolation, and it ensures that all transactions are executed independently without interference from one another. One transaction cannot impact the outcome of another transaction. So if they're both updating the same row of the same table, one transaction will have to wait until the other has completed. D is for durability. It ensures that once a transaction is completed, it remains so even in the event of a system failure. So if there was a power loss during the transaction, it cannot leave the database in a inconsistent state. And if the transaction is committed, then the data must still be in that state once the power is restored. Good news is that every single operation that you make to Dataverse or to SharePoint from the Power Platform is wrapped up in an implicit transaction. So it will always be consistent, isolated, and durable. And it will be atomic for a single insert, update, or delete. But what about the example that we were just looking at, where you want atomicity across multiple operations? Let's see a really simple example of atomicity in SQL Server. So I'm going to insert a record into our reservations table. We have one row created. If I go and quickly just delete that and then wrap this up inside a begin transaction, check that there's no records, so you can see 0 records there, and I'm going to run the begin transaction. Now if I do a select again, I will see that record that I've just created. There it is. But if I go over into a different session, which is an implicit transaction, you can see 0 rows here. And the reason is because this transaction is isolated from this transaction. Now if I say commit transaction here, I will now see that that has still got the row in this transaction. Obviously, well, the transaction's finished, but if I go over into the other session, this implicit transaction can now see that record. What about the atomicity? Imagine I was to go and create 2 records here, and that I was going to violate a rule, which is the guests cannot be null. Okay, so I'm going to delete all the records I've created so far, and I'm going to begin transaction here, and then insert this second one, and this will fail. So you can see here, cannot insert the null. And because this has failed, we want to roll back the whole transaction. Now, if I perform a select in this transaction, I can see that I've got one row created, but if I go to the other implicit exit transaction, you can't see that row that was created because it's isolated. So let's add a rollback and then run that. And now if I select, we see no records, and of course, no records over here, which is all good. So we can automate this by wrapping this up in a try catch. So I'm going to put begin try here and the begin transaction. And at the end, I'm also going to say end try. And then if an error happens, I'm going to roll back. But if it all succeeds, I'm going to put the commit transaction. I'm going to now run this, and you can see that the first row was inserted, and then the second row failed because it violated this null. And now when I do the select, you see we've got no reservations because the whole thing rolled back. But if I say now, put in a valid value for this, and I run this now, you can see here we've got both the rows are inserted, and then because everything succeeded, it committed, and we have 2 rows. How do we make that happen in Power Platform? Well, up until now, this functionality has been reserved for only those who can write C# plugins. And so I've got a reservation here, and I've got a plugin that's preventing me from creating a reservation for the same date. So I'm going to duplicate this up. And you may have seen this, you may have implemented these kind of pieces of logic on projects, business process area that assisting is not available for these dates, because that is the C# plugin kicking in. So I'm going to just delete this so that we can start from afresh. And here I have a flow that is going to do similar to what we had in the transaction in SQL Server. It's going to create 2 reservations, okay? So, and because the second one is for the same date, it should fail. So if I now test this and say manually, so we'll put in a listing, which is that listing, and then the date, which is going to be duplicated, and then the customer ID. And this could be run from another flow or Power Pages or Power Apps. I'll run this flow. So it's successfully run. And you can see here that the second request to add that reservation failed, which is as we'd expect it to. And so you can see that the reason for it failing is this listing is not available, and that's that same plugin kicking in. But the problem is that we now have a record there, and this is creating an inconsistent state. We want to make sure that this process is atomic. There is that atomicity. And the way that we can do that at the moment, before we had PowerFX functions, is we can add something called a manual compensation. And that would be a step that we'll say run after, and we'll configure to say when the previous has failed, this manual compensation will then go and try and delete those 2 reservations. So if I save and test this, and if we now run this, let's just pick the one that just failed. So there, it's run it now, and you can see that the second add failed, and now it's run this manual compensation because the previous scope, it's wrapped up in this scope here. This scope failed, and therefore it's tried to delete the first one, which succeeded, and then it tried to delete the second one, which didn't succeed because it wasn't created in the first place. So if we go back to our app there, and we refresh, you'll see there is no reservations. And so that creates this atomicity. But the great thing is now with PowerFX functions, we don't need to do this manual compensation, because quite often this manual compensation step can get quite complicated and often is forgotten about in implementations. So we've seen how a cloud flow can do a manual compensation of a transaction. But I'm just going to give you a quick primer on creating PowerFX functions, and then I'm going to show you how they can use transactions. So I'm going to go and add in a new function into my solution. I'm going to call it echo. Give the description as echo, and I'm going to add a new input parameter and have that as a string. And then I'm also going to say have an output as well, which is the reply, and have that as string. So what this allows us to do now is to have a formula which will respond for the reply. So you can see here I'm responding with a shape which includes reply, and it's of type string, and then I'm using string interpolation to output the message that was the input plus the date. So I've actually added this into a Power App already, and the way you do this is you go to add data and select environment. So in my echo button here, what that allows me to do then is to say environment, and then I can select, this in this case is Contoso Echo, and it's asking me for a message. So I'm going to put in foo. What we can now do is select the output of that, which is reply. And this is just going to add this into a collection, a log, and you can see there's the echo response. So let's have a look at that working. And there we go. There's the echo with our input message plus appended on the date and time. So if you remember before, we had a Power Automate flow, a cloud flow that added in 2 reservations for the same date. Because we have a plugin, we will see how to do this in Power Effects later on. But at the moment, we're using C# and we'll see that second reservation fails because it checks to see if there are existing reservations. And what we did before, we added in a manual compensation. So we'll only run this if the previous scope fails, and we'll delete any records that have been created. And we want to avoid having to do this. So here I have a Power Effects function, which is an atomic transaction test, and I accept the same parameters as I did in the Power Automate flow that we saw last time. And I have a formula here, which is inserting, using collect, into the reservations, 2 reservations for the same date. So you can see here, the first one, and then the second one. Of course, this will fail. If these 2 inserts were running inside a Power App, then the first one will stay even though the second has failed. But because this is running inside a transaction and we have atomicity, the failure of the second one will cause the first one to be rolled back. So if I was to do this in a Power App, rather than using a Power Effects function, I have a button here which does something very similar. So we're adding in 2 reservations for the same date into this collection called reservations, and then we are adding those into the reservations table here in one statement. So we would think that if one of these failed, then all of it should fail, right? That is not the case. So I've got a catch here which checks to see if anything fails, and then I have a check here to say it finds how many reservations there are for that particular listing, and then it will show it's failed if there is more than 0 and success if there is 0. If I run this, it's showing the failure. So here it's saying that the requested operation is invalid. Then it's saying it's failed because we have one of these reservations still left over because it's not atomic. We've got another button here which is using the function. So it does something very, very similar, except for this time we are calling that function that creates those 2 reservations. So you can see we've got our Contoso atomic transaction test, and we're passing in the same values as we did for the individual direct creates on the table. But this time, this function will create both of them inside a transaction. So we have the same catch and we have the same check to say that if one of them fails, then we should have nothing left over. So if I run this now, there we have got the failure because the call failed because one of them failed, but we have no reservations left over because the whole transaction rolled back. And this is a big, big deal. You could not do this up until today. You would always have to do manual compensations. It was something you could only do if you were using the web API or writing C# plugins. And so now we have this functionality available to us in low code. So that's the A in ACID. The I in ACID is for isolated, as we saw earlier. This is very important. When you don't have isolated transactions wrapping up your process, it can cause all sorts of random errors. And this is why I think you should really take notice of PowerFX functions. Imagine you have an online rental reservation system. Only a single property reservation could be made for any given date. Let's imagine that this is a popular site, of course, and 2 people are trying to book at the same time via Power Pages, calling a cloud flow. If one user completes their reservation before the other, then the second Cloudflow would check for an existing reservation and then fail because the date was not available. This is good. But if both users click reserve at the same time and the site starts 2 Cloudflows at roughly the same time, the flows would first perform a query to check availability and then create the reservation, thinking that it's available. And if both the queries to check available execute at the same time because the flow execution is not isolated or queued, then a duplicate reservation would be created and the property would be double booked. This is not good. Even if we created a single PowerFX function to do the check for availability and then add the reservation, as we've seen, it would run inside a transaction, but this alone is not enough to solve this problem. The 2 transactions are isolated, yes, but it will mean one will not see the reservation that is created by the other until the transaction is completed, and then it's too late. So how do we solve this problem? The answer is database locking. There are 2 types of locking possible in Dataverse: optimistic and pessimistic. Optimistic locking is only available when using the web API, not through low code at the moment anyways. And the way it works is optimistically assuming that there is no concurrency, so it allows both transactions to execute at the same time. A row version column is added to the table so that when an update is applied, the version of the record that was read is compared to the version that is being updated. And if the version is the same, it will succeed. But if another transaction has updated it since the version was read and now it's different, then the transaction will fail. Even if we could use this in low code, it wouldn't solve our problem easily. So this is where pessimistic locking is so powerful for preventing concurrency issues. So now we have the two cloud flows calling the reservation process, and now the check and create reservation is done inside a PowerFX function. Before we check for availability, we have to create a lock. We can take out an update lock on the listing records so that if another function tries to update that same listing before checking for availability, it will have to wait to take out the same lock until the first transaction has completed. This way, we can guarantee that no other reservations will be created until the first transaction has completed. The waiting transaction will then continue and ultimately fail because there's now no availability. Until PowerFX functions, this was only possible using C# code deployed as a plugin. Let's take a look at the example where two flows that are creating reservations for the same property happen in series, that is one after another. So you can see here we are calling this reserve listing flow for a particular property, and then we're calling exactly the same flow for the same parameters a second time. So what's going to happen here is it will execute the first flow and then it will execute the second flow, and which would mean the second flow should fail because we're trying to book it for the same date. So if I run that now, as before, it's giving us success because there's only one reservation. So if we go and look at the flow runs, the first one succeeds. It will first get the existing reservations, which will return no records. And then after that, it checks to see there's no records. And then if there are no records, it will then go and add a new one and then respond with the reservation. If we look at the failed flow, this is the second one that runs, we'll see that actually it gets the existing reservations and then it goes down the false path because the number of reservations is greater than 0. So it terminates and doesn't execute the add row. So we only end up with a single reservation. What about if we are going to run these in parallel and concurrent with each other? Because there is in Power Apps, a concurrent function that allows us to run two flows or two patches or collects in parallel with each other. So we've got the first one here and the second one wrapped up in this concurrent. Both will be fired off at the same time. What we're seeing here is that this test failed because the number of reservations created was 2. And the reason being is that we've got these two flows that were started at the same time and they both succeed because they both query to see if there's any reservations, and there aren't because it's executing at about the same time before the other one has had a chance to create the reservation. And obviously this is not good, so how do we fix it? Here I have a PowerFX function which accepts very similar parameters to our flow that was being called by the Power App. And the first thing it's going to do is it's going to do some validation, validate that the listing is actually found based on the ID we're giving. And then it will do a count rows, filtering the reservations based on the date range that we're trying to book. And if there is more than 0 records returned, it will return an error saying the listing is not available. If that is okay, then it will then go and create a new reservation similar to the way that the flow worked. Let's take a look at how we're doing that. We're calling that from our Power App. If I open up this reserve function, we'll see that we're doing similar to when we were calling the flows using the concurrent function, except for this time we are calling environment.contoso reserve listing. It's similar to the echo function that we created, and we're passing in the parameters, and then we're doing it again. So we're calling this function using the concurrent, so it's going to happen at the same time. But what we're also doing is we're passing in an additional parameter called lock. You can see here's the lock parameter, and what that does is if it's set to true, it is going to update the listing record that we're trying to add these reservations for. And because this is in a transaction, if I update this listing record in this transaction and then try and do it in a parallel transaction, it will create an update lock, and the second transaction will have to wait until this transaction has finished. And so this means that they will effectively then be queued up, which is exactly what we want so that we don't get duplicate reservations. So we'll call the reserve function with locking set to false. Both those PowerFX expressions have run in parallel. Both the reservations have been created, and therefore it's a failed test. But if we set locking to be true and we call reserve in concurrent again, you'll see that one of them is going to fail because it has waited for the second one to complete, and then it's determined that there is an existing reservation. We only have a single reservation created, which is correct. So what we've done is we created that wait, that update lock, which has then meant that the second transaction will wait and we will only get the correct number of reservations created. So wow, that is a lot to cover, and you're probably going to need to go back and take a second watch. Transactions are a hidden superpower of PowerFX functions, and so I hope you like them as much as I do. Now go and tell everybody you know. So until next time, thanks for watching. Cheers.